All right, here we go. Urinary system. It is kind of funny because you and the sophomores are doing the same things right now. I don't know if any of you have sophomore friends or sophomore siblings. This is what they're doing in biology, is talking about the urinary system. Now, we'll go slightly more in depth than they do. I'm joking. Of course, much more in depth. But it's always fun. So actually, there's some pieces that they've done, lab pieces, that we're going to do some similar pieces, which I like. So, the pieces of the system. This lovely diagram that starts you off shows you our pieces. Very straightforward. You've got 2 kidneys, right? Don't forget those adrenal glands that are on top of the kidneys, right? That again are part of what system? Endocrine, there you go, the endocrine system, producing those hormones, right? But you'll see there are some hormone productions that do care about here in this chapter. From those kidneys, you have tubes that come down. What do we call those tubes that lead out of the kidneys? The ureters. Those ureters come down to the bladder. Everybody always thinks of the bladder as being the main organ of the urinary system, but no. The bladder is just simply the holding tank, the storage spot. And then from that bladder, we have one tube that leads to the outside, which is called the urethra. And again, both guys and girls do have the urethras. They're in different places, but they both lead the same place, outside. So let's keep rolling here, talking about some of the anatomy. Come on now. Of the kidneys. So kidneys, and this is actually what we're going to do on Thursday. We have some dissecting we're going to do of some nice kidneys to see. Reddish-brown bean-shaped organ, like a kidney bean. The reason why it's called a kidney bean is because it looks like a kidney. And it's enclosed in this tough, fibrous capsule. Do you remember when you were dissecting your pigs, that there was literally this coating around the kidneys, and you had to like break that off to see the actual kidney itself? That's that capsule, that fascia capsule that's holding it in place there. The kidneys are positioned retroperitoneal. Let's use your words here. What does retro mean? Old or behind. Yep, I like it. And then peritoneal, we're talking about the actual peritoneal cavity, right? So it's actually outside of the abdominal type cavity, kind of up against the back there, between the 12th thoracic and the 3rd lumbar vertebrae, and that left kidney is just a little bit higher than the right. There's a depression in the middle of the kidney that leads to a hollow renal sinus, in which the blood vessels and nerves and lymphatic vessels and the ureter all enter. That would be this little spot right here, right? Where everything is coming into that middle depression, the middle part of the bean, right? Inside the renal sinus, there is what they call a renal pelvis that's subdivided into a couple of different pieces there. I'm not interested that you know all the different pieces, but just giving you a tour. You can divide the kidney into 2 main pieces, and I do want you to be comfortable with this. That we have the medulla and we have the cortex. So the medulla is what houses all of these tubes, all the blood vessels, all the lymphatic vessels, the ureters, where that's coming in. And the cortex is what actually does the functioning. It's what holds the nephrons. And the nephrons are the functional unit of the kidney. This is the thing that actually does the work. Sir?
What does medulla mean?
Yeah, it just means like outer layer, if I'm not mistaken. I'm not positive, but I'm pretty sure that's what it means. Inner layer. Cortex is outer. I have to look that one up. I may be mixing myself up on that. We'll check it out. The functions are functions of the kidney. Their goal is to really regulate 3 big pieces: the volume, the composition, and the pH of our body fluids. And they're removing metabolic wastes from the blood in that process. So we've talked about the kidneys being a filter, right, for the blood. And so yes, they are filtering out these wastes and these bad things out of the kidneys, out of your bloodstream, into the urine. But they also are what's helping you to maintain the water balance, the electrolyte balance, and the pH balance. That's the next pieces from chapter 18 that we'll look at next. These balancing of these three main pieces. The kidneys are what do that. So it works very nicely to put these two chapters together. The kidneys also help control the rate of red blood cell formation. Again, by secreting that erythropoietin from that gland on top. Why can't I think of the name? The adrenal gland up on top there. And they also help regulate blood pressure by secreting another hormone called renin. So lots of work. The kidneys are kind of unassuming, just these little beam things sticking back in the back of your back. Back in the back of your back. But they do have some pretty significant functions that happen there. Okay, yes ma'am. That's a good question. I don't know. I know that you can live with only one kidney and not be significantly affected. Does that cause that one to wear out? I'm not sure if they've done any sort of studies that show that. I'd be very curious to look that one up. I don't know. You would tend to think it might, but I don't know. It's a good question. If you find something, let me know. I'd be curious. All right, the blood vessels coming in. Are you comfortable this is a huge part of this urinary system? If the kidneys are going to act as a filter for the blood, then you got to get the blood into the kidney, right? So, right off of the abdominal aorta are these renal arteries that branch off and send that blood to the kidneys. I think your textbook said something on the order of like 30% of your blood volume at any time is in the kidneys. Well, it's a lot of blood that is going through these guys. You had a question? Mm-hmm. I don't think, it's a good question. I don't think that there is a market that you can actively sell them. I'm fairly certain that that's illegal. I'm not positive about that, but I'm fairly certain. Because, are you comfortable that'd be very easy to exploit? Oh, Hannah, she's pretty weak. I can just take her and kidnap her and let me steal her kidneys and sell them. And I'll make tons of money. You know what I mean? So I'm fairly certain that is in there. Does that mean it still happens? It does. There's certainly a black market for that kind of stuff, yeah. She's not weak. She was right here. She's right.
Just walk up to the hospital and say you want to donate your kidney? Like, how does that work? You have to be like,
it's a great question. So I think most of the time, folks who are offering to donate an organ like that, again, it's a fairly major surgery to take it away from you. It would be a fairly life-changing thing because there's medication you have to take, there's complication risks. So normally that's if it would be like your brother who needed a kidney, and because you're genetically very similar, you would probably be a match, so you can give it to him, otherwise he would die. That's usually what would happen. She says, oh, that might not be a better... No, I'm just kidding. Tony's a good guy. So rarely, in other words, rarely would there be somebody like Hannah who would come in and say, hey, I just want to give my kidney to somebody that it matches. That would be pretty rare. Does that make sense? It does happen. So there's a process to make sure their blood types are similar. There's a whole series of things they go through to make sure the kidney won't be rejected, or as little chance as possible for it to be rejected.
So you know how when people are waiting for kidneys, they go through dialysis?
Mm-hmm.
Could you go through dialysis without actually having to, having one kidney?
You can, sure, if you have only one functioning kidney, sure. Right, yeah. The point of dialysis is it's trying to mimic what the kidney is doing by, again, removing the waste products from the blood, but it's not nearly as efficient. and you can only go through that for a period of time before it just doesn't work as well anymore.
It says that a person that had their kidney removed as a child or during surgery, it could take up to 25 years for there to be like slight function loss, but
Okay.
it rarely happens. But if you're born with one kidney that works and one that doesn't, there will be more problems with that.
Okay.
But you could have high blood pressure.
Well, which makes sense, because it's trying to slide all that blood through that one kidney. Yeah, cool. Thank you for looking that up. I appreciate that. I think, I will say this, though. Let me make my little plug here. All of you are driving, right? All of you have licenses? Every single one of you. And I would say there's very little excuse for you not to be an organ donor. If you are not, come see me. Let's have a conversation. Because are you comfortable when you die, you don't need your organs? Okay? You don't need them. And it makes so much, again, the lists are thousands of people long that you can, did you guys ever hear Mr. Boyer talk about this? Cool, of course. So, I mean, his daughter's story is a fantastic story. If you don't know the story, Mr. Boyer was our Bible teacher before Mr. Soper, and had a daughter your age who died very, very rapidly, unexpectedly one day. But she wanted to be an organ donor. She had told her parents this, and I want to say there was on the order of like 10 different people who got a piece of Aaron, who, 20, 30 years later are still functioning and are still living because of that gift. It just would be a foolish thing to not have that in your license. So I encourage you, let your parents know, or talk to them about that. Talk to me. I'd be glad to have a conversation with you about that as well. Again, are you comfortable? You are dead, right? You don't know. You won't have some scars, places. No. You won't know. It's gone. Okay. Yes. Shh.
Brain or like organs for because they want to be like revived or resuscitated in the future. What do you think about that?
Right. So, I want to make sure you guys can hear these questions because they're asking good stuff here. Have you heard of these folks who want to take their head, honestly, it usually is the whole head, that they take and freeze? And a big thing that was maybe 50 years ago, this was a huge thing. They'll take, like once you die, they'll literally take your head and preserve it in, it's usually a nitrogen kind of bath, super cold, so that sometime in the future, when Eric invents a way for us to reanimate you, then you'll be living and alive and right. What do I think about it? I think it's a humongous waste of money. I'll be honest with you. Yeah. Huge waste. That's what I would say. All right. Let's keep going, my friends. Cryogenics, that's what they call this. Let's keep moving. Okay, so are you comfortable that those renal arteries, as blood comes in, they start branching, right? They start going into smaller and smaller pieces until you get these things that we call the afferent arterioles. These little tiny blood vessels carrying oxygenated blood towards the nephrons. And they're showing you pictures here. And I'm not super impressed with the pictures that are present here. I'll show you. So we're over here on page 482. Please, my friends. Thank you. Don't be confused, because it looks like a broccoli stem, right? Like, here's this straight piece on the bottom, then here's this curly yellow and red all over the place. We'll talk more about this, but we're paying attention right now to the red pieces, those, of course, being the blood vessels, right? And so the blood vessels are bringing the blood to this nephron, right? So that it can be filtered. We're going to talk much more about how that works shortly. And again, it's going to go through this process and then be dumped back out into the venules back into the renal vein to be carried back to the heart to get reoxygenated. So we'll keep going here. The nephron itself, what is the structure of this? Well, let's talk about the amounts first. That one kidney contains 1 million of these nephrons, which is fairly impressive. It's an awful lot of these little tiny pieces in one of those little kidneys. And each of those nephrons has kind of two main pieces. You call it the renal corpuscle and the renal tubule. Now, a corpuscle just means like the head of the broccoli. You know, like a blob is the best word I can use to come up with. Okay? And then a tubule obviously would be a tube, right? So this nephron kind of has a blobby piece and a tubey piece. Very scientific words. Blobby piece, tubey piece. So that the corpuscle, the renal corpuscle, is what actually does the filtering. It is the filtering part of the nephron. And it's made up of a ball of capillaries that we call the glomerulus, as well as the glomerular capsule that receives the filtrate. So you have blood vessels, right? That's what capillaries are. And you have these glomerular capsule, the tubes, that are in this blob mixed up all together. You see it? Here's the blob, right? So here's all the blood vessels, right? The glomerulus we're talking about there. And then the capsule is the yellow tube that's kind of all intertwined with it. Does that make sense? We'll talk about that. We'll talk about that. Yeah, we haven't even got to that piece yet. We're just showing you the anatomy first. But this is where that's happening. This whole process. Right. Over 1 million in each kidney. Yes. There's pulling out one and letting you look at it. Okay? The renal tubule, remember we had the renal, go back here, the corpuscle, right? That's the top part, the glomerulus and the glomerular capsule. And then the renal tubule leads away from that glomerular capsule, and it becomes this proximal convoluted tube. Let's break down the words. What does proximal mean? Nearby, close to the starting point. What does convoluted mean? Like it's all mixed up, it's all twisty and turny, right? And then tubule means tube. So it's the closest mixed up tube to the glomerulus, right? So it becomes that, then that leads down into the nephron loop, which we'll talk about in a few minutes, and then into the distal convoluted tube. And all of those tubules join into a collecting duct. So let me show you here. Proximal convoluted tube. So sorry, here's glomerulus. Glomerulus here. Proximal convoluted tube. Here's the nephron loop. You'll also hear it called the loop of Henle. That's an old school name for it. And then here is the distal convoluted tubule. And all of that comes into the collecting duct. And those collecting ducts then merge, and eventually that's what forms the ureters, right? Because we're taking that filtrate and we're sending it out of the kidney into the bladder. We talked about the blood supply already, that the glomerulus receives the blood supply from a fairly large afferent arteriole. Remember, afferent and efferent just means before and after. So the arteriole that's before the glomerulus, we call it the afferent arteriole. The arteriole that's after the glomerulus, we call it the efferent. Remember, the lymph system had the same piece, because you had the afferent and the efferent vessels around the lymph node. Same thing. One means before, one means after. Yes?
Do you stretch out a nephron like that for how long would it be?
It's a great question. I don't know the answer to that. It would be decently long. Of course, we are talking about, there's 1 million of these in our one kidney about the size of your fist. So it wouldn't be super big, but comparatively, yeah. It's a lot of surface area in a very small area. You're correct. Okay. I think that we are ready to dive in to how this guy works. Whew. But we've only got 10 minutes. I'm not sure we're going to make it all the way through here. Here's a close-up. I want to make sure you can see. Afferent arteriole, efferent arteriole, right? Blood vessel before, blood vessel after the glomerulus. Here's the actual glomerulus, right? That coil of blood vessels. And then it's surrounded by that glomerular capsule, the tube that is around that big bud of blood vessels. A bud is actually a good way to think of this. Like the buds on the trees you see. I mean, that's really what a glomerulus looks like. That blobby blood. Are we cool? And you see that that's just zooming in this one part. They've taken off the blood vessels here. So this is just the tubules, right? The proximal and distal convoluted tube, and then the nephron loop. They're showing you those pieces here. All right, so 3 pieces by which we form urine. Glomerular filtration, tubular reabsorption, and tubular secretion. I think we'll spend probably this time here talking about glomerular filtration, because that's really the key point here. So urine formation begins when the fluid portion of the blood is filtered by the glomerulus and enters the glomerular capsule as glomerular filtrate. Can somebody translate that for me? It's a lot of glomerulars. So the filtration happens when, from the glomerulus, right? The blood, parts of that blood, parts of the stuff in that blood, come into the glomerular capsule. Are you with me? Some parts of that blood get pushed out from the blood vessel into the glomerular capsule. We'll talk about what in a second. Yes, absolutely. But I want to make sure you see that. And they are calling that this glomerular filtrate. Okay? What's been filtered, the stuff that's been filtered out of the blood into this glomerular capsule, into the tubules, right? How does that happen? Like, what causes that? Well, it's because of these pressures. The main force responsible for moving the substances by filtration through the capillary walls is the hydrostatic pressure of the blood inside. Remember these pressures we talked about? These osmotic pressures and the actual just blood pressure itself? These things are what help to push some of these things out. In the past, we've talked about this for oxygen, right? And carbon dioxide in the respiratory system. But now we're talking about different pieces. We're talking about the water in particular, right? Osmosis is the movement of water, right? So we're talking mostly about water. But we're also talking about some of the other pieces that's being filtrated as well. The electrolytes, the waste products as well. So there's a nice picture here. And this is in your textbook. They're on page 489. And they help you to see how this works. So, we have the pressure from the blood, right? Just the pressure that's pushing in that little capillary. That there's an outward force of 60 millimeters of mercury. I'm assuming that's what they're measuring this by. I'm not sure what they're going with millimeters here. The inward force is, that you have this plasma that doesn't want to leave, right? So that is the plasma colloid osmotic pressure. It wants to stay in, that's resisting it. You also have an inward force because there's fluid in the capsule around the capillary, so it's pushing the opposite direction. But overall, the net force is going to be pushing out. This 10 millimeters of mercury pressure pushing out. Do I care that you know these numbers? No. I'm not interested in that. What I do want to make sure you understand, though, is there is a net movement of these fluids and particles out of the capillary. Are you with me? So from the blood vessels, in the glomerulus is just a bundle of blood vessels. From that blood vessels, we're pushing out, again, this water, this waste products, these proteins. Are we cool? What affects that filtration rate? Well, the amount of pressure that's pushing there, right? So the amount of osmotic pressure that's there, how much water is present is going to play a role in that, as well as how much pressure, how much fluid is in that capsule already. That's going to play another role in that. If these arterioles constrict or dilate, it's also going to affect, because now I'm having more blood or less blood come in. So we wouldn't actually call it urine until you've collected it all together and putting it into the bladder. But it's the pieces that would make that up. We're going to talk much more about what those things are yet. We're just getting through the actual process of it. Sir?
There's something like next to your abs, like doesn't it like it's all these different things coming together, but it all comes out like one thing? Is it like all like dissolved together, or is it like?
So all of these little tubules, and maybe I'm not answering your question. Let me see if what I'm going to say helps. Every one of these nephrons is connected to one of these collecting ducts. So you literally have 1 million of these little ducts all coming together to form the ureter. So that process of taking the filtration from this nephron and that one, all of that is what makes the urine itself. So it is the combination of all those things together.
But each one is pretty much making the same thing since they're all being given the same.
Well, it all depends on, because the blood itself is not always completely uniform. Depending, because again, you're eating, you're exercising, the body is always changing the composition of what's in the blood based upon what you're doing, what you're eating. So no, I would say it's definitely different everywhere. And the urine you get at the end is this compilation of all those pieces together. We cool? So on the average, how much filtering is happening? 125 milliliters per minute. Okay, doesn't mean a whole lot to you. But how about 180 liters per day? So take a 2-liter bottle of soda, right? And do 90 of those. That's what your kidney is doing every single day, which is pretty impressive. Now, the good news is you don't have to pee 90 liters worth of urine every day. Whew, that would be a bit of an issue, right? Most of that fluid is reabsorbed. And we're going to talk about this process. Your kidney is just amazingly efficient at, if you have enough water, it's going to expel it out. If you don't, man, it's going to just keep recycling and reusing until you get every drop of water you possibly can get out of your body. So I think we're going to stop there, because that's a good place to be stopping. May I encourage you that if you have not yet read this section, I would certainly recommend you do